And then I want to welcome everybody to this panel and say these are all awesome colleagues of ours that work really hard behind the scenes to make the data science educational stack. And, you know, Berkeley's vision for data science education, like, is open to the, you know, throughout, and like so many elements of it are like, you know, what we've already talked about, the textbook and the homeworks in the labs, but there's huge elements of it that are the infrastructure behind the scenes. And there are people, you know, contributing in different ways to these projects that make sort of like the Berkeley Data Science and Data 8 ecosystem happen. I will also just add humorously that there's nothing like a deadline. And so people seem to like create new innovations around this workshop because they've like sped up to make something awesome. And Yuvi Panda admitted that the littlest Jupyter hub was created for this workshop. I think it was 2 years ago. Not for this workshop, but, you know, like, it rolled out and had some documentation for this workshop. I will reflect on our organization. We did a lot of work to get our like outward-facing materials ready for this workshop. So, you know, it's great, like, that we have this moment that we're sharing our things out with people where we have new things to share. So reflecting on that, turning it over to Yuvi Panda with what he's got new for us this year.
Okay, well, thanks, Eric. And no, Little Jupyter was built for this workshop. Like, if this workshop was not there, it might have happened at some point in the future, but who knows? Cool. So that's a lot of people. Thank you for being here, everyone. So we constantly are working on random bunch of things. The thing that I've been working on, one of the things we've been working on recently is, you know, suddenly all classes are remote, and like everyone seems to be using Zoom, and the word Zoom is also now used for generic video conferencing in the way that Skype used to be. So that's pretty cool. But it's also, you know, like, it's a separate service. And Berkeley is lucky enough that there is a site-wide license, like, you know, like all Berkeley users can have like free pro Zoom accounts. I know that's not necessarily true everywhere. And it's always also interesting to see how you can integrate like a capability like video or audio into another system, just to see how that goes. So what we've done is I've worked on a project called Jupyter Video Chat, where the idea is that you embed video chat, you know, and just like chat and screen share features into a Jupyter hub via Jupyter Lab, which is like, you know, like a newer, more customizable user interface to the Jupyter project. So I'm gonna now paste the link to like, so if you are on the workshop hub, which everyone who's been taking any of the workshops here, they have access to. I'm just going to paste the link to that. The username is, you can use any username, and the password is, I believe, correct horse battery staple, and you can use your email address as that. And then I'm going to screen share to see how it's like. So the goal here is, like, you know, we want to try and replicate as much as possible the experience that a bunch of students would have, just, you know, sitting around a lab and working in some form or way. And of course, real-time collaboration is one important part of that. But, you know, like, if you're 4 students in a lab, you're not actively going to be like all typing onto the same computer, right? But you're going to be looking at each other, you're going to be talking to each other, and possibly looking at each other's screens. So we were just trying to like replicate all of that in there. That is my screen. Can people see my screen? Okay, so we just trying to replicate all of that inside the Jupyter Notebook. So this is the workshop hub. If you log in, you should be able to see the same screen. I can probably, you know, go and look at, I don't know, random notebooks. Let's say this is a lab that like we both are in the class and we're all working on this together. And I want to, just work on this alongside someone else. So on the right side, you'll see there is a tab called Project Video Chat. And if you select it, it'll show you the projects and the teams that you can join video chat for. Now, these are just made up. I've just made them up. But the idea is that if you are, if you are taking the 16A course, and you are part of like team A in project 1 and you have a different class and that's team C, those will all be listed here. And separate from that is, you could possibly also just join random chats. So you can have, just like people like setting up individual chats between each other to collaborate on a project. So if you're there, I'm going to join the 16A project chat. It's going to be interesting. And it basically then lets me video chat from inside there. And if anyone else is there and joins in there, they would be able to see me and join me on the 16A project chat as well. Ooh, someone else is there. Right. Wow, it's a lot of people. Hey, hello. Cool. So anyway, yeah, and I can screen share from here. There's this chat. Oh, someone muted me. Oh, that makes sense because you can hear me through Teams. Thank you, whoever muted me. I'm going to screen share. There is moderation features that let people mute everyone and do all of the usual moderation things. So this is using a project called Jitsi, which is an open source video conferencing application that is really, really nice. We are just using the public instance that is available to everyone. This is nothing but, of course, like if we were to run, like a large class on it, we would run our own Jitsi instance, which is actually surprisingly easy if that's the thing you want to do. And we would probably write a little Jupyter Hub plugin that automatically sets that up for you as well and write up docs for it. But yeah, the goal would be that you would just be able to use this to do what you need to do. And I'm going to try and see if I can specify, if I can share my screen. This is the button. I always forget. It's this. Sure, why not? I'm trying to see which is this current. There's too many, I have too many windows. Let me close some. Okay. Let's share. I'm going to share this screen now. There we go. And Jupyter. Okay. So the interesting thing here is that I can now hide this project video chat. And to me, this looks like I am on Jupyter Lab and I'm doing normal Jupyter Lab things. But the other people there can still see my Jupyter Lab window and hence can see what I'm doing. And I can hear them. So the video is not gone away. It's just hidden. So it doesn't interfere with this. So the experience that we are thinking of is if you have a group of 5 people and you're all in the same space and you all share your screens, you can still hear the other person because you're all not muted. And if whenever I want to, I can just open this up and go look at someone else's screen, and that's going to be okay. But it's not going to be on all the time. So that's the hope that it's going to go through and deal with. And of course, more people use it, we'll find out where it is and isn't going to be useful. There is built-in chat into in Jitsi itself, and there's ways to raise hands and stuff like that. How do I? There's chat. Aha. So there's people who already said chat, and usernames are automatically set up. So if you have users logging in using your whatever authentication, that will directly propagate to this, and they don't need a second layer of authentication here for anything. And this also lets us build more things on top. Like one of the things that people are talking about is the ability to just drag a notebook and send it to someone, and possibly also show a diff, of just your notebook and their notebook. So you can be like, hey, this works for you. Why doesn't it work for me? and then be able to very easily see that in a visual way. And just other ways, because this lets you basically just transfer files and whatever data you want back and forth. So this is a fairly new tool. I think like I started working on it only like maybe 3 weeks ago or something, and it's got a long way to go. So if you think this would be something that would be useful in your teaching setting, or you have thoughts and suggestions on how this would go, please let us know, and we would love to like have people use this. Okay. Yes. Eric, should I go or do we have questions? What are you going to do?
Oh, I'm speechless. I can't even talk. I'm just like, that was the live demo of all times. There's a few questions you could take, or we could wait till later. Like, how many people would this support? How long till people would get access to this?
Mm-hmm. This is using the public Gypsy server. So that is, I'm just going to send a link to it. It's run by the open source project. And I think it supports like 20, 30 people easily at a time, but you can always run your own server and that can support like several hundred people without a problem. And, and whoever has access to your Jupyter Hub will have access to this, and you can secure that in however way you want. And yes, someone asked if you can get it in a current Git clone of Jupyter Lab. Yeah, I can send a link to it's a Jupyter Lab extension and a Jupyter Server extension. I'll have a link out to how you can install it. So yeah.
Fantastic. All right, we can come back. Keep throwing your questions in there, but let's let Ryan go. Feel free to throw in questions for Yuvi, and we can come back to it. It's so cool that you're there. It's a little like schizophrenic because now like he just sent half the conference over to the other video chat, and so like maybe we could just have like a desk full of laptops all on different chat clients. But without further ado, we also want to present one of the unsung heroes of Berkeley data science education, Ryan Lovett, who is a little bit behind the scenes, but has done amazing work getting RStudio to work on the Jupyter Hub, which it has increasing popularity.
Hey, Eric, can you hear me?
Sounds good. Go for it.
And you can see the slides?
Yep.
Hey, so thanks for that, Eric. Yeah, so I'm Ryan Lovett. I work for the Department of Statistics at UC Berkeley, and I've helped with the Jupyter Hub deployment for a time. So the talk is using RStudio at Jupyter Hub. I'm going to go into the history of RStudio and our hub a bit and explain why we're using it, why we're deploying it the way we are, and the current status. I suspect this could be boring in a good way because I think a number of people are already using RStudio on their hubs, but maybe you'll be interested in the history. So back in fall of 2016, the staff department here created a course to introduce a broad range of statistical methods used to solve data problems in R. It was called Stat 28, and it was a follow-up to Data 8. It was going to have about 60 to 100 students, and we had been running our hub for a while, and I thought this could be a good opportunity to use R-based Jupyter notebooks on the hub. And as many of you know by now, if you want to run R in Jupyter, you install R itself, an R kernel, whatever R packages you need, which is analogous to installing Python, a Python kernel, and Python packages. So I showed the instructors the R kernel and demoed R notebooks, but it wasn't their cup of tea. They really wanted RStudio instead. And RStudio, it's basically a full development environment for R, whereas the classic Jupyter notebook we run for Data 8 has a user interface that focuses on a single document at a time. you could tell RStudio's got the multiple panes, multiple tabs. The instructors were already familiar with RStudio because they used it daily in their own research. And they've been using it in teaching, and they felt it was important for the students' academic careers, their future research experience, and eventually their professional opportunities for them to know RStudio. So we pivoted away from thinking about R on Jupyter Hub and looked at how to deploy RStudio. And while many students could install the software on their own device, and many did, the instructors still didn't want, many of them were first or second year students. They didn't want them to have to deal with managing software on their own, much in the same way, the same concerns apply to Jupyter. And so at the time, the way of providing RStudio to the masses was with RStudio Server. And RStudio Server is a product that enables people to run RStudio in their browser by logging into a shared system. The idea would be that we could stand up some virtual machines in the cloud for the compute, manage a file server, maybe a directory service to manage all the student accounts. And RStudio Server Pro has additional features like integration with Google Auth, load balancing, admin access to user servers, and there's a laundry list of other things. The Pro features are free when used for teaching, but they're not open source. And at the time, the more I evaluated what was needed from an RStudio Server deployment, the more seeing what work was involved, the more I thought that it basically resembled what our Jupyter Hub was already doing for us. Our hub was already doing auth. At the time it was Google Auth. It was already giving us administrative access into user servers. Kubernetes was already managing and distributing the compute load. We already had file services running. It was open source, so we didn't need to deal with licensing. It was doing everything we needed it to, except it was running Jupyter as the user app instead of RStudio. And conveniently for us, RStudio, like the Jupyter Notebook, like Jupyter Lab, it is actually a web app. Those who use it may be familiar with it as a desktop app, but it's actually a web client and server all-in-one running on your own device. And that's how RStudio Server is able to host it on the web. So because it is a web service, it meant that we could proxy it through Jupyter. And the reason we knew we could proxy it was because we had successfully proxied a different web service. It was for a Cogneuro course that was running on our Jupyter Hub. The instructor had wanted to be able to display fMRI images using this Python library that they had called PyCortex. It had a built-in web service. It was like a WebGL canvas thing. And when you used PyCortex on your own device, you could access that web service through localhost. But in our hub deployment at the time, it wasn't possible to access that through Jupyter Hub. And so Yuvi, he conceived of a way to proxy web services running within the user server. If I recall, I think he said it had occurred to him when he was working at Wikimedia, and I think he was gonna like proxy various DevOpsy things. Anyways, we implemented it initially, the proxy initially for the fMRI visualization on the hub as a Jupyter Server extension that's now called Jupyter Server Proxy. It used to be called NB Server Proxy. So we adapted this for RStudio in what is now called Jupyter RSession Proxy. The first few iterations were a little rough around the edges, but Yuvi applied his Midas touch, and I think it's worked fairly well since then. And this is the initial user experience of the Jupyter extension. Basically, students log into the hub, and in the classic notebook, they click on new RStudio, and this would launch in a new browser tab. Since then, there's now Jupyter Lab support from the Jupyter Lab launcher. So the RStudio environment was fully integrated into the hub session. The same auth, the same files. The extension was initially on the separate Stat28 specific hub, but then it made its way to the main data hub. And so Eric started to advertise this feature quite a bit to the R-based courses, and it became very popular. Yuvi moved the R environment to a separate hub, r.datahub.berkeley.edu. And when students visit it, instead of having to visit new RStudio, the hub launches RStudio automatically because /RStudio is the default URL. And RStudio works the same way on Jupyter Hub as it would on RStudio Server. You can run knitr, you can display visualizations, you can upload and download files, you can develop Shiny apps. And it also works the same way as it does when running RStudio on a personal device, except on the hub, it has access to whatever compute resources we allocate user servers. So by having RStudio available this way, we've been able to support classes we never originally intended. And actually, instructors in other non-Jupyter Hub classes would end up referring their students to this hub. They'd find out that some of their students would have trouble with their own devices that prevented them from running RStudio, like maybe some antivirus problem or some system update gone awry, or they'd spill coffee, or they had a Chromebook and the desktop version of RStudio couldn't run on it. So by running RStudio in this way with all of the users' files online, the compute online, they just need access to a web browser. And this should be fairly boring, but this is because I think many of you've seen it before. It's a demo of distributing a hyperlink, which will launch a student server. It uses NB Git puller to fetch materials from a Git repo, and then it'll launch RStudio, which is the most popular way that instructors have their students launch servers. We can't tell RStudio to launch a specific file for us the way we can with Jupyter. So students are required to use the file open feature from within RStudio to access their R-based files. Analogously, you can also run Shiny apps this way. There's a Shiny server app from the RStudio folks, and there's a Jupyter Shiny proxy extension. And again, this is another demo which you may have seen before. Because all of this is open source, the Jupyter community has made other contributions. There's the proxying of Microsoft's code server. Yuvi developed Jupyter Desktop Server, which proxies no VNC. I think Tim Head did the proxy for the Microsoft's code server. Somebody else has proxied Google's OpenRefine. And yeah, you've all seen that before. So lastly, there's many good reasons for running RStudio via RStudio Server. If you don't have existing Jupyter Hub infrastructure, or even if you do, but you can easily support Jupyter Hub and RStudio Server together, if you're using the pro offering for research, but you can budget for the non-open source features you need. RStudio within Jupyter on Jupyter Hub is the right choice for us because of our existing instructional infrastructure. Our hub is authenticating students against our preferred directory service, which is now actually Canvas. We're already maintaining the Kubernetes cluster and file services. We can use the existing student and instructor documentation. We don't have to come up with some other stuff for accessing RStudio Server. We can use existing methods and like NB Git puller for students to pull down homework assignments, labs, and projects. And of course, the proxying mechanism we use for RStudio also enables us to run these other web apps besides RStudio and Jupyter. And that's it. Hope that was boring for everybody who knows RStudio on Jupyter by now.
You're muted, Eric.
Thank you, Ryan. That was great. Such a great implementation, and it's nice to hear your story that it's like you're figuring out that it's leveraging on a bunch of engineering that's already done, and you're like, why build a new thing when we have built 3/4 of it already?
Yeah, laziness was a big.
That's not what I meant.
I mean, it was. When I started to think about deploying this whole new app, I'm like, wait a minute, we're already doing this Jupyter Hub. Why try to reproduce all of this? And so in the end, I think a lot of good came out of it. And a lot of people jumped on the proxy idea, which is really cool. The EEX Hub now has the desktop proxying and the code server stuff, which is really exciting. So
yeah, I mean, and I guess this is a little my impression of like part of Ryan's job is sometimes there's some kid who lost their computer and needs help, and like having this resource there, sometimes it's like a backup resource, right? Where it's not necessarily like, if you want to be awesome at stats, learn to run RStudio on your nice computer. But if something happens, there's a cloud-based thing to support learning or to support the the Chromebook loaner program. So it's like, it's about making things work for lots of kinds of users, not just being like a single pathway.
Yeah, and for whatever reason, once students found out about RStudio running on Jupyter Hub, they seemed to prefer it because there were students who had nothing wrong with their own device. They just ended up using the hub. So that's just what the usage showed. That's the instructors came and told us that. So.
Right. It's like we have these students today that are like the I generation because they grew up with iPhones. Now they're like the cloud generation, that they just grew up with cloud computing. It's, it's instinctive to them. All right. There's a bunch of questions in the chat. Let's keep those coming, and maybe Ryan can take a look at some of those. Yuvi and Chris are answering some of the questions for Ryan, but keep it coming. I would like to move over to Chris Pyles, who is the author of Otter Grader that we've talked about a lot. Really quickly, I don't know, there's somebody here sharing their screen. Ashok, I don't know, I can see you, but I would love it if you turned off your video. I can't turn off Ashok's video for him. Chris Pyles, are you ready?
Yes, I am. Can you all see my screen?
Looks good.
Okay. So, hello everyone. I'm Chris Pyles. I'm the student lead of the infrastructure team at DSEP, which is the team that built and maintains AutoR Grader along with some other software that is maintained by DSEP. And I'm also on the Data 100 course staff. So this bin. a big push to get AutoGrader adopted by Data 100, and they are running it for this summer's offering. So hopefully all goes well as we test the beta release of version 1. But this presentation is going to focus on what is Otter and what are some of its new features. So to start off, Otter is a local modular auto-grading solution that is designed to be customizable to any instructor's assignment pipeline. Its original intent was to be an entirely local auto-grader for classes smaller than about 50 students, where instructors would collect notebooks in whatever way they prefer, just download every submission onto their machine and use Otter to grade them entirely locally in Docker containers. Since that, at the beginning of the fall, it has grown quite a bit into kind of this auto grader that is very customizable. It has many third-party LMS integrations, including Berkeley's LMS stack, which is Canvas and Gradescope. It has support for, like I said, local grading. It has a client package that allows students to run checks in the notebook, similar to the OKPy client package. It has an optional deployable grading service, so you can set up a VM on any cloud provider and use that to have students submit their assignments to and grade in that way, similar to the OKPy service. And we are on the verge of the version 1 release of Otter. So we've been doing a bunch of testing this last year in different classes. We're beta testing version 1 this summer in Data 100. Version 1 includes several updates, including a new tool called Otter Assign, which is very similar to JAssign for OKPy. And what that does is basically allows instructors to create a master notebook with questions, solutions, and tests all in one document. And then Otter Assign parses that out into the necessary files to distribute to auto-graders and students. And Otter is backwards compatible with OKPy. So any adoption of Data 8 materials will be usable with Otter. I believe the sharing repo is also going to be auto-graded with Otter pre-installed. So the test structure is the same as OKPy, the same OK test format where you have just a Py file with a test global and some cases defined in .test format. So coming back to Otter Assign, like I said, it's a fork of JAssign for OKPy that abstracts away. Sorry, I'm getting an echo. Can whoever's unmuted turn their microphone off? So it abstracts away things like Otter Generate and the OK test format from instructors. So all the instructors need to do is just write a Jupyter notebook in a specific format, and everything else is left to Otter to take care of. So the Otter Assign format is actually very similar to the JAssign format in that it starts off with a question declaration that provides some configurations, such as the name of the test, whether the question is manually graded, and the number of points that it's worth. This is then followed by the solution cell and then optional test cells with comments delimiting them and indicating whether or not the test is public or private. So that will get parsed into some other documents. So I can show you kind of what this is going to look like. So this is, let me make this bigger so everybody can read. This is the directory. So this is a master notebook for Project 3 of the economics connector that I don't know if Eric's had a chance to talk to you guys about. But Otter Assign has an assignment metadata cell that defines some things for Otter Generate, files needed for generating the assignment, instructions for submission, et cetera, et cetera. And then this is just a notebook, just like you would write, but with the inclusion of solutions and tests. So if I run Otter Assign, it will generate some PDFs for me of that notebook exported in different formats, and will also generate my Otter Grader zip file so that I can use OKPy. So now I can go into this dist directory. There is an AutoGrader directory that contains a version with solutions but no tests. And there is also a student directory that contains a version of the notebook with no solutions. So this is what the solution version looks like. We can see that it's added the check cells in place of tests, but it's kept the solutions in there and kept the output of every cell. The student version has been sanitized. So with Otter, assign built in is AutoGenerate, which generates this autograder.zip file for you that has used configured grade scope for use with Otter. And AutoGenerate basically defines the files needed by Gradescope to autograde an assignment. So it abstracts away the need to write these kind of Python files from the instructor. So all the instructor needs to provide is the tests and any support files needed for execution, like data files or Python scripts that get imported. So it also, Otter.notebook, which is the class that runs checks for students, includes a robust logging protocol. And that log is submitted with the student's notebook, and it is used to check, to verify a student's scores. And there is some nice output down here on Gradescope with the output of every test that's run so that instructors can help debug student submissions and so that students can see if they fail public tests, why they're failing on Gradescope. So moving on from AutoAssign, we come to AutoGenerate, which is what I've just described. Instructors need only provide OK formatted tests and any support files, and Otter takes care of grading student submissions in Gradescope's containers. It also has support for the auto upload of PDFs of student submissions to separate pre-configured assignments on Gradescope so that to facilitate the easy manual grading of questions. And there is a nice template format for Otter when it does exports that I don't have right here that kind of makes every question take up the same amount of space so that you can easily define your grading regions on Gradescope. So the Otter Gradescope workflow is very simple. You start by generating the configuration zip file from tests and assignment resources using the AutoGenerate tool, or if you're using AutoAssign, that is wrapped into the AutoAssign call. The student uploads their submission, which is a zip file created by calling the export method of the notebook class. Gradescope will spawn a container that grades a submission. The results are written to a JSON file in that container, and Gradescope parses those and optionally uploads PDFs of notebooks to another assignment for manually graded questions. So this is the output we just saw. So as Eric mentioned at the beginning of the call, we have a new feature that's hopefully going to be part of the beta release soon. It is Otter.R, which is an Otter-compatible R package for auto grading. So it's designed to grade R scripts, R Markdown files, and Jupyter notebooks with R kernels. And it's going to be integrated into Otter. This is a very new feature, something I just started hacking away at, I think like Tuesday night. So I want to stress that it's completely tested, but hopefully it will be soon, and we can get people start using this as soon as possible. It's got a somewhat different test format philosophy than does the Pythonic Otter grader. It's basically almost a wrapper for the teststat library and uses teststat formatted tests to run autograder tests. So in this example, we just use the check method of the Otter library to run the test in this file. And this is what the test looks like. You define a test metadata string, which is just a YAML formatted string that contains some metadata for each test. And then you just have teststat calls in the file that run the tests. And the passing and failing of each test is determined by the output of this teststat call. And all this is parsed by Otter. It includes the ability to integrate with AutoGenerate and Gradescope. It will be runnable in the Otter grade local grading format. It's compatible with it will be compatible with AutoAssign, so that way all of the parsing and things, if you're using R and Jupyter notebooks, will be able to be done. And it's going to be fully integrated. It should take some time to shoehorn everything into place, but hopefully soon we will have this ready to go into production. Another tool I wanted to briefly discuss was something I I had a call with someone about a week ago, and we got talking about the semester in the cloud and how do you have secure exams. So this is a tool called JExam, and it is an exam generation tool that uses a master Jupyter notebook, very similar to JAssign and AutoAssign, to create Jupyter notebook exams that are randomly generated from a predefined list of questions and versions of each question. It's a little different in this format in that it uses raw cells in notebooks rather than code blocks to delimit questions within multiple versions. And it allows instructors to create, anywhere from a few different versions of an exam, or to, if you have enough questions and versions, completely individual exams for each student. And this tool will also include soon a Google API client integration that will allow instructors to, with 2 calls from the command line, create the exams and then auto email them to their students, just using their Google key. So the JExam format is very simple. You start with a raw cell that delimits the question. Within each question, there can be 1 or more versions, and you just define, very much similar to the JAssign AutoAssign format, a question cell, a solution cell, and then test cells below that. And this gets parsed into a master notebook or a student notebook that includes Otter or OKPy if you're using OKPy, with grading public tests if that's pre-configured, and a solutions notebook that includes the solutions and the checks for every question and version. So I want to touch a little bit on our future roadmap for Otter. One of the things I mentioned, the main thing right now that we're working on is Otter.R. So hopefully that'll be ready to go out soon. We're also going to be starting this summer on furthering our Canvas LTI for auto-uploading grades from grading locally. We have some Microsoft collaboration in the pipeline, including things like Codespaces integrations and a GitHub Classroom LTI. We also want to get more involved in bringing Otter closer into Project Jupyter and things like Jupyter Notebook and Jupyter Lab. So things like an Otter Submit extension are kind of what we're considering. And front-end support for Otter Service, which is the grading server that I talked about at the beginning, that's going to be very similar to the OKPy interface, but somewhat different because of the different design aspects. And I just want to touch a little bit on writing tests. We are developing a resource for writing auto-reader tests. Basically, tests in the OK test format just contain configurations and the expected input-output for those tests, and they're formatted as Pythonic doc tests. And we recommend that you use a master notebook tool like JAssign or AutoAssign to generate these files automatically. But there is an online tool that I built that will help you write tests in the OK format, where you just provide the code output and some other configurations for each test case and generate, and it'll create the Python file right there for you. And in addition to that, we also have some documentation in the pipeline, hopefully that will be finished in the next couple weeks, about test etiquette, ways to write autograder tests, especially given the nuances of the doc test format and other considerations that are specific to more data science courses like seeding and things like that. And I think that brings me to the end of my presentation. So I hope this was helpful to everybody. And I'm going to turn it back over to Eric.
I'm going to just give a nice wow there. That was awesome. Thanks, Chris Pyles. You're killing it. I also want you all to know that Chris Pyles is a junior at UC Berkeley, and he's doing all this. And he has a job. I mean, a summer internship. Okay, moving on to Chris Holdgraf and Jupyterbook 2.0.
Okay. Can you all hear me?
Yep, sounds good.
Okay, cool. Let me share.
Do you want to put your video on so we see you in the bottom corner, or?
I can. I have no idea how to do that.
You might not be able to if you're not like in the client or whatever.
Oh, okay.
Looks good. We see your presentation.
You can see my presentation. Okay, cool. Okay, cool. So my name is Chris Holdgraf. I've been at Berkeley for several years now, working with the Jupyter team and across the different both infrastructure teams and also kind of the education and research focused groups on campus. I work a lot on the Jupyter project across a bunch of different kinds of things. A bit on Jupyter Hub, a bit on something called the Binder project. But what I want to talk about today is a tool that we've been working on for sharing collections of notebooks in a more traditional format, which we call Jupyterbook. So in case anybody is interested in this, let me actually copy paste this into the chat window because that'll probably be easier. Oh, okay, there's formatting that comes along with that. Good to know. So this is a link where you can just get these slides in case you're curious about checking them out. The presentation is going to be going pretty quickly, and I have a lot of links scattered throughout these slides. And I think that the goal for that is to cover a lot of material and then allow you to use this as like a reference as you want to learn more about Jupyterbook and how you might be able to use it. And before I go any further, I just want to say, even though I'm going to be the one talking about this project and the broader Jupyter project, all the stuff that I'm talking about is really backed by this broad, diverse ecosystem and community across Jupyter. People are kind of all over the place working on this kind of stuff, and there's no real one person or a couple of people working on it. So really thank you to all of that community because they're really the ones that make this possible. So really quickly, I just wanted to touch on some of Jupyter's goals as a project and then feed that into a bit of how Jupyterbook is designed. Jupyter's, I think, primary goal is to create an open, inclusive community of peers that together build really awesome open source technology that enables interactive computing. And one of the core goals of that is to create tools that are modular and composable. So like little building blocks that can be put together for some use cases and other pieces can be used for other use cases so that they don't only work as like a single vertical kind of stack. And we also put in a lot of effort to create standards with other organizations and try to leverage and piggyback on pre-existing standards rather than creating new standards ourselves. And then finally, we also want to prioritize infrastructure that works across a variety of vendors, a variety of infrastructure. Really, Jupyter is trying to enable interactive computation anywhere in the world, no matter what your kind of use case or your constraints are. So then that takes me to Jupyterbook. And before I go further there, I just want to recognize a few of the other lead PIs on the Jupyterbook project. So Jupyterbook is one tool that's being spun out of a broader project that we're calling the Executable Book Project. And that's a collaboration between a few different institutions. If anybody's curious about that, you can check out some information about it there. So as I said before, Jupyterbook is fundamentally a tool to allow you to share collections of Jupyter notebooks in a more traditional kind of way. So what do I mean by that? Basically, a lot of you probably have a folder on your computer that's just got a bunch of Jupyter notebooks in it, maybe some Markdown files in it. And those notebooks are a bundle. Like they may have relevant information between them. They may be a step 1, step 2, step 3 set of notebooks through a process. And what Jupyterbook wants to do is to allow you to share that collection of notebooks in a way that lets people kind of like quickly browse through it and explore it and treats it like a more traditional, website or a traditional book that you might find on the web. So some of the goals of Jupyterbook, it wants you to be able to display that notebook content in a more familiar and kind of beautiful, in some ways more simplistic form, but also to add some extra features that are really focused around authoring those documents and also reading those documents, because mostly you're going to be sharing these notebooks with a classroom or a set of collaborators or something like that. We wanted to add in a lot of features that are needed for something like publishing, so for things like citations and cross-references and stuff like that. But we also wanted to connect it with more traditional, or not traditional, with more modern workflows and interactive computation with kernels and JavaScript widgets and stuff like that. And then finally, we wanted it to be relatively easy for people to deploy and share it with other people, again, on any kind of infrastructure that's out there. So the easiest way to learn about Jupyterbook and the place to go to just follow up on this in general is jupyterbook.org. Jupyterbook.org itself is a Jupyter book. So everything that's there is something that you can build yourself. And just to really quickly show you this, for lack of a better word, like the page just kind of looks like a book, or it looks like how a lot of books are shown on the internet. So you've got your main content here in the middle. This page is actually powered by either a Jupyter notebook or a Markdown file or something like that. I can actually see that if I click here. I can click this source file and it'll show me the actual text that's underlying this page. On the left, you get a table of contents that lets you browse through different parts of your book. You can nest some of these contents inside of each other. So if you just want to show certain kinds of pages, depending on where people have landed on your site, and then you get some nice features on the right, like, on this page and everything like that. That's just a very, very fast, high-level introduction to the interface. So how do you actually create a Jupyterbook? Well, you can pip install Jupyterbook from PyPI. It's just a small Python package. And if you want to create just a lightweight kind of demo book for yourself, you just type Jupyterbook create my book name. And what Jupyterbook will do is it creates a folder and it places in a kind of minimal set of content files and configuration that you need in order to build a book from that folder. So let's take a look at what that actually looks like. So inside of this folder, I see a couple of different things. Basically, this config.yaml file, which is a configuration file, a table of contents.yaml file, and then a collection of content files, Markdown files and notebooks. So that config.yaml file is how you configure everything in your Jupyterbook. It's how you, add a title or enable certain kinds of features, that kind of thing. The toc.yaml file defines your book's structure. It's how you say, this page comes first, and then this page, and then these pages are nested underneath the second page, that kind of thing. It's basically what defines that left sidebar in the final Jupyterbook. And then these content files can be written in a variety of formats, but the most common ones are Markdown and IPyNB files. And those actually make up the bulk of your book itself. So once you have a structure on a folder like that, you can use Jupyterbook to actually build a final output book from your content in those configuration files. And the way that you do that is just by running Jupyterbook build, and then you pass it a book name. And sorry, I should say, you pass it like a folder, a path to a folder where your book exists. So when you do that, what Jupyterbook is going to do is it goes inside that folder, it finds all of your raw content files. For any files that are executable, like an IPyNB file or a Markdown file that has executable content in it, it will first execute those files and it'll cache the outputs. And so by caching, what I mean is in future iterations, when you build your book, it's only going to re-execute those files if their code cells have changed. If the code cells haven't changed, then it's just going to pull from the cache and it'll be much faster to build your book the next time. So after this, we have this populated set of materials that has the outputs of all of our execution. Next, what Jupyterbook does is it basically resolves a whole bunch of references and enriched metadata on each page and between the pages. And this is where you can do things like insert equations and citations and cross-references, the kinds of things that you would need in a traditional kind of book that you might publish in a publisher or something like that. And then finally, after it's got this enriched document under the hood, it can then output that document into a variety of different output formats. And right now, and what I'm going to focus on today, the most common format is HTML, but the plan for Jupyterbook is to allow for lots of different other kinds of output formats, probably most notably PDF, but also things like EPUB files as well. So once you do that, once you've run Jupyterbook build and you point it to a folder, you'll get a new folder inside that's just called _build. And that build folder has all of the sort of output artifacts from that process. And basically, in the case of HTML, that just means you've generated a little self-contained, fully functioning website. OK, so that was the kind of build process of Jupyterbook. But the next thing that you're going to want to actually do is write some book content of your own and sort of leverage the different features that are there. And the most important thing to cover there is that Jupyterbook supports Markdown primarily, but it supports a very particular flavor of Markdown that we call mist Markdown. For those of you who aren't familiar, Markdown is a really, really common markup language across a lot of different projects, but there isn't any one single standard for what Markdown means. There are what we call flavors of Markdown, and some of them support certain kinds of syntax and features. Others support other kinds of syntax and features. The most common standard in Markdown is something called Common Mark. And this is actually the flavor, more or less, of Markdown that Jupyter notebooks support. But CommonMark doesn't support a lot of the kinds of things that we need in order to get things like citations and references, a lot of the things that we need for publishing. And so what MIST Markdown does is it builds on top of CommonMark Markdown and then adds just a couple of extra pieces of syntax to give you that functionality. You can check out a MIST Markdown overview at the Jupyterbook documentation. And this covers a lot of the different extra things that you can do in MIST Markdown. Again, I want to reiterate, though, that MIST Markdown is a superset of CommonMark Markdown. So basically, any Markdown that you've written in a Jupyter notebook will already work in the case of Jupyterbook. And then you just need to add extra things to it if you want to get extra functionality for something like Jupyterbook. The two most important extra concepts in MIST Markdown are things called roles and directives. And these are kind of like functions, but in Markdown, as opposed to being in Python or R. You can give them different kinds of names. You can pass them arguments. You can pass them metadata. You can pass them content. And then when your book is rendered, different kinds of things will happen as a result of how you've configured these roles and directives. So just as one example here, on the left, I'm showing how you can insert a figure into a page. So you call a figure directive, you pass it a path to a PNG file. Here we're tagging it with some extra metadata. And most notably, we have this my_label that we've added as a label for the file. And here's an example of a reference in Jupyterbook. This is how you can refer to things on other pages. And here I'm just using ref. That's the shorthand for the reference role. And then I pass it my_label, and then it knows to find this label here and then add a link and a title out to that figure that might be on this page or on another page. You can also control your code cells. So everything that I've described so far has been done in Markdown. But as you know, a code cell does not have Markdown in it. The way that you can control this kind of behavior in code cells is by using tags. So tags are ways that you can insert metadata into the Jupyter notebook. And you can use tags to sort of control different kinds of behavior, like hiding inputs or hiding outputs or removing a cell entirely, that kind of thing. And then finally, I just wanted to note that you can actually use another open source tool called Jupytext to provide two-way synchronization between text-based versions of a notebook and the full rich kind of IPyNB file. And this can actually be used in Jupyterbook at build time. So you can define the structure of a notebook, but entirely in Markdown. And Jupyterbook will know to convert that into an IPyNB file when it executes it and populates the output. So that way you can have all of your content in just raw text. So it's much easier to diff and much easier to work, to collaborate on. But the final output will look like it was originally a Jupyter notebook. OK, so then the very last thing that I'm going to do is just cover a few interesting features in Jupyterbook. But I'm going to go very, very quickly through them just in the name of time. There are links at the bottom of each page that gives you more information about how you can use that thing and how you can learn a little bit more. So for one of the benefits of Jupyterbook is that you can have semantic content blocks. And that basically means that you can tag certain parts of Markdown with extra information that says, hey, this is like a note, or this is a tip, or this is a citation, or this is an aside. And that allows you to sort of enrich your final output with different kinds of visual styles and that kind of thing. You can also, as I mentioned, insert citations and generate bibliographies. So if you have a bibtec file, you can reference entries of that big bibtec file and then insert a bibliography into your book. And the same thing goes for figures and captions as well. You can generate a figure, generate a caption for that figure, and then create references to that figure on other pages of your book. As I mentioned before, there's a pretty interesting execution and caching machinery in Jupyterbook. It uses another tool that we work on called Jupyter Cache that ensures that you only have to rebuild content when the code itself has changed, unless you force it to do so. And that drastically speeds up the builds for longer or more complicated books. And you can also do interesting things like insert the outputs of executing a cell somewhere else in your book. So there's a small Python module called glue. And what you can do is assign a key to a particular variable. Like say I generated a random number or calculated a statistic. I can assign that statistic a key. And then on some other page, I can say, insert the value that this key points to over here. So on the right, for example, I generated a figure on one page, and I also generated this bootstrap statistic here, and I can insert them directly into my text. So if you want to show, a statistical analysis or something like that, this is a way that you could accomplish that. You can also selectively introduce interactivity into your book. As one example here, you can select certain kinds of contents to either be shown or to be hidden by default, and you can ask users to sort of click through to show that, which is really useful from a pedagogical standpoint, because you can do this to provide like hints or to provide answers that you don't want to be readily available, that kind of thing. And then finally, you can also connect your Jupyterbook static website with a variety of interactive live environments in the cloud. So this is one example of Binder, but as I'd mentioned before, behind a lot of these pages are IPyNB files. And in this case, when you build your Jupyterbook, it gives you a link. When you click that link, it'll take you directly to a live interactive session that runs the actual Jupyter Notebook and allows the reader to sort of explore and do things as they wish in there. So finally, I just want to note again that Jupyterbook, like everything else in the Jupyter project, is supported by a broad, diverse, inclusive community, and it's largely made up of people just like you. A lot of people who are at universities, community colleges, individuals who are just enthusiastic about this kind of stuff. And if you're interested, then I welcome you to join the community, to sort of pitch in, participate in these kinds of projects, and to get involved. There are lots of different ways that you can do that. Sometimes it's writing code, sometimes it's supporting the project in many, many, many other ways that you can support one without writing code and focusing on the technology. But if you're interested in that, feel free to reach out, and I'm happy to chat. And then finally, I'll just give you a couple of links here. Again, the Jupyterbook documentation on the top, the sort of meta project for all of this, executable books in the middle, and then finally, a bit of information about the Jupyter project and myself. So thanks very much for your time. Eric, I'm going back to you.
Yeah, I'm here. Sorry, I'm unmuting. But you're still sharing, so I'm like double.
Okay, how do I do this?
Leave it on that slide.
Stop sharing. There we go.
Or either way, you can leave it on that last slide. I will just quickly go to the last question, Chris Holdgraf, about accessibility.
Oh, can you hear me still?
Yep.
Yeah, I was actually just typing in a response to that. So right now, I would say the Jupyterbook is like sort of accessible, but not accessible. So the current version of Jupyterbook that I just described is literally only 2 months old. But working in accessibility is like a huge part, I think, of making it a more sort of professional, like high quality tool. And it's something that we're going to be shifting more of our focus on in the next couple of months. Jupyterbook builds on top of a bunch of other tools in an ecosystem called Sphinx. And one of those tools is the theme that actually provides like the design and the visual look of Jupyterbook. And right now we're doing a bunch of work in there to add like ARIA labeling and contrast audits and stuff like that to ensure that those are accessible at least at that base level. And all of those improvements are then going to make their way into Jupyterbook as well. So it's something that we really care about and we want to improve. Also something that's not our expertise. And if others have like thoughts or opinions or developer time or whatever, then we would be happy to collaborate on that kind of stuff.
How does Jupyterbook compare to Bookdown?
I think it's quite similar to Bookdown. Jupyterbook took a lot of its inspiration from the Bookdown project. For anyone who's not familiar, in the R community, they have a really excellent project for stitching together collections of R notebooks and R Markdown files called Bookdown. Bookdown uses a slightly different stack under the hood. It uses something called Pandoc for managing a lot of its sort of stitching things together and resolving references and things like that. Jupyterbook is in many ways similar, in some ways complementary. I think one of our goals was to have something that was explicitly language agnostic. Having something in the Jupyter ecosystem means that it could basically be used for any open source language. And while Bookdown has support, or like RStudio has support for Python and R, it doesn't have that same kind of polyglot focus that the Jupyter project does. The other thing that we wanted to do is, as I mentioned at the beginning, build on top of a pre-existing ecosystem that was in the Python community. And so most of Jupyterbook are actually a collection of modular components that work in this documentation engine called Sphinx, as well as contributions that we've made to other projects that were already existing in the Jupyter ecosystem, or in the Python ecosystem. So part of it's also just kind of a decision about the stack that powers the end product. But at the end of the day, I think that they're both, I mean, obviously I think Jupyterbook is great. Bookdown is also a really awesome project as well. And I would encourage you to explore it and decide sort of which one seems to make the most sense for your use case. It'll feel very familiar to use either one of them though.
Okay. I want to go to Pyles really quick. There's some commentary about rendering your PDFs in Gradescope or rendering them, like generating them. I guess there's different workflows there for Jupyter notebooks. Chris, did you want to talk about that? Because I know you've been working in like different ways to manage the workflow of like the PDF written answer part of Jupyter Notebook.
Yeah. Sadly, I can easily say that's the hardest part of figuring out how to build an autograder is how do you handle written questions. So yeah, Gradescope unveiled their IPython notebook or Jupyter Notebook renderer for programming assignments. So now whenever you go and look at the code submission of a programming assignment and it's a Jupyter Notebook, they will actually render that and a textual output for every cell of the student submission in their thing. So it's not like it's not like a live environment. It's very much like, I guess, Jupyterbook, that it's a static rendering of the student submission, but it's still there. So it's not like just the raw JSON anymore. So there's kind of two philosophies here. One is that AutoGrader questions or assignments on Gradescope support having manually graded questions, so a manually graded rubric. And so if you want to keep everything in one place, you can, now that they have their renderer there, go through and grade it like a normal assignment and just have, the AutoGrader score and the written questions just there in one place. And I mean, at smaller scale, that's actually a really feasible solution because of their renderer and some of the nice ways they've gone about putting it in place. It's just sometimes a lot of scrolling. But when you're at a very large scale class, I think it makes it difficult to assign grading and have, things like students' questions, their response lengths can vary. There's a lot of weird things that can happen. And so when you're at scale and you're organizing the grading of 500 plus students, it's just easier to have a separate assignment and a fixed length template. So that way every student's response is going to be in exactly the same spot with exactly the same size. And you can just, have that PDF generated when a student submits and put that into Gradescope's PDF grading infrastructure, which is very good at what it does in terms of fixed length templates. It's just like grading exams on Gradescope. And of course, the downside of that is that now you have two separate assignments on Gradescope that really represent one assignment. But if you're using any coding language to do your grading, it's a pretty easy solution to solve. So I mean, those are kind of the two schools of thought about grading manually graded questions. And I mean, it's not anything that we have a solution for really. It's just Otter supports both, so do whatever you want to do.
Thanks, Chris. What else? Do we want to go through the chat? Most people are sort of answering things in real time in the chat. Chris and Yuvi have been pasting in a lot of resources.
Actually, yeah, on that point, one thing that I didn't mention was for anyone who's used the previous version of Jupyterbook, the new version is a pretty big rewrite of it. And the pattern for using it is very similar, but it will require you to make a couple of changes. So I added a link to a very short kind of informal migration guide into the chat window in case anybody is coming from a previous version of Jupyterbook into this version.
Yeah, I mean, might be worth touching on. I mean, there's certainly this issue with Data 8 where you're not supposed to redo the textbook of Data 8, and that's on the no derivatives license right now, but certainly people will be wanting to make some similar versions or something that's not a derivative. We want to be able to support you to adapt Data 8 to your class, but at this point the instructors have reiterated their interest in it not being forked per se. Other questions from the chat? So Chris, I don't know, you had been talking about sort of like voila and interactive stuff. I know that you are definitely like got your fingers on the pulse of interactivity. Like ThebeLab, voila. Chris, do you want to just like talk about
Yeah, sure. So
the other one that came up also in the chat was like, what about students doing like, dashboarding as assignments in a class, which maybe this group would be interested in.
Yeah, and I think that those are both kind of related to each other too. So the short version is that there's been this kind of like proliferation of tools that exist in between like a fully featured live Jupyter Lab or Jupyter Notebook interface and something just like a static website. And a lot of those tools have focused around this idea of dashboarding. So basically, you use Python code or whatever language code you want to generate basically a little miniature web app. And you expect that people are going to use that web app without ever seeing any code. And so another thing that someone mentioned earlier today was Dash in the Plotly ecosystem. The R community also has a tool for this called Shiny. So a relatively new one in the Jupyter world is called Voila. And basically what Voila does is you give it a notebook, it executes that notebook from top to bottom, and then it shows the outputs and hides the inputs, basically. And so what you can do then is use an interactive visualization Python library like IPyWidgets or like Bokeh or like Panel in order to only show those widgets. And you can do things like connect them with like a Python kernel under the hood. You can do some pretty sophisticated things and basically build your own little miniature graphical interfaces to let people explore data or download data or do whatever they want to do. There's still some work that needs to be done to make that like easy and kind of seamless in the context of a Jupyter hub. Right now, you can certainly run your own Voila applications locally, and you can get the whole thing set up. But we're trying to find ways that we can facilitate that kind of thing in the context of like a shared learning environment in the cloud, like a Jupyter hub. So hopefully there are improvements to come along those lines, things like making it really easy for a student to generate a notebook that creates a little web application. And on a Jupyter hub, we want that student to be able to share a link to their collaborators that allow them to interact with that web application. Whether that collaborator is like another student, or it could be somebody like an instructor that wants to review their work and that kind of thing. So I think that hopefully there's more to come in that space. It's kind of it's a pretty cool new area of development across many different projects. There are also a few links that we dropped in the chat window in case anybody wants to see more.
Great, thanks, Chris. If I could bring Ryan Lovett back, I guess, there's a lot of people interested in this group on the like Python R, which is the one, which is better for teaching students. There was we had a little debate on, I think it was like on Wednesday night. I don't know, Ryan, just as like, you're somebody that supports both R and Python users. I don't know if you just wanted to comment on like your experience with like teaching workflows or, sort of like teaching workflows, instructor workflows.
Sure. I mean, I don't really have an interesting answer. Yeah. So my job is to support our instructors and researchers. So if they say they wanted to teach using, a ball and string, then that's like, okay, let me source that and try to find the best ball and string I can. Yeah, so in statistics, our community has been using R for quite a while. But more and more people are starting to use Python. Fernando Perez, he's now in our department, in the Department of Statistics at Berkeley. And so there's a lot of excitement around Python. So, I mean, yeah, so if our folks say that they're going to be teaching with R, then I'm going to try to deliver that. I'm not here to make a comment upon how they should teach. I anticipated that like one course would end up using our notebooks, and they didn't. They didn't want that. So we went to RStudio. So, and I think, in the Jupyter ecosystem, like I think people want to provide the best tools possible. And if somebody else provides that, then, I mean, I've had these conversations with people, then the Jupyter folks want to make sure that, people are aware of those other tools and use them. And, some amount of friendly competition helps, I think. Yeah, so I don't really have an opinionated response. There are tools that I prefer using. And sometimes when I'm consulting with like a grad student, I end up, sharing like, oh, this is something that I think is useful to me, so you may want to check it out. But each person has their own ways of being productive and their own history. So they may have been taught that the best tool is Fortran, and so they don't want to, then learn a whole new tool. So then I try to help them with that.
Thanks, Ryan.
Sure.
Can we go back to Yuvi Panda? I guess a couple questions are like, one is like roadmap ahead for future projects or future things you see happening in this space. I mean, you're like really sort of tapped into like who's engineering in Jupyter. What do you see as like, future things that we will get, future pathway?
Mm-hmm. I think from the Jupyter Hub perspective, there is definitely work going on in just expanding what it will be used for from outside of just Jupyter. Again, like RStudio is fairly well established now. There is more and more work happening. So sort of try to change from Jupyter Hub is infrastructure for running Jupyter notebooks or even data science stuff to like more broader things, as you can see with VS Code or like Linux desktop. And both in terms of, making it like a lot of the technical pieces already exist for like just having more and more people run this, but just making it like more possible, like little Jupyter Hub, for example, like then having it possible for people to use RStudio from that, and then just do the connection of like the social aspect of little Jupyter Hub, which is basically like anyone can start and run this in like 30 minutes, and connecting that with like, yeah, cool. Now let's add RStudio to that. Let's add like VS Code to that, or like a bunch of other things. So it's like really looking at integration and making it easier for people who don't have the resources that UC Berkeley has to be able to do the things we want to do. So yeah, and some of the other cool things that I see happening are like a lot of them are in like the distributed-ish computing space, where you're teaching with Dask or in some cases like Spark, rather than just like on a single core as we're doing now. There is like a tiny project that's trying to like add USB support to Jupyter notebooks on Jupyter Hub, so you can teach electronics that are like connected to your local computer through Jupyter Hub. which, I think if you don't know anything about USB, that sounds like completely normal. And if you do, that sounds completely like out there. So yeah, like it's basically now that the infrastructure is stable enough that people are building things that would have otherwise made no sense to build, but now we're like, oh yeah, that's actually cool, and like people start depending on it. If the Jupyter discourse is very good place to keep an eye out on more of these things.
Awesome. I guess there's another set of questions that's like, okay, we could teach somebody to set this up and roll their own for data 8, but maybe if we're trying to train data scientists, we want them to be able to do like big data kind of things, like, big queries, big data sets, big, SQL and Python integration, or, Spark, or, what is the like. And I guess one of the Jupyter Hub questions is like, does it become unwieldy? Does it become too big? Does it become hard to do, to do this on the big data scale?
Yeah, that's a great question. I think not, mostly because if you look at a lot of the commercial investment, like from companies and other organizations that are putting whatever they are putting into Jupyter Hub, like they are really coming at it from a perspective of, like big data style stuff, and they're interested in running Spark, they're interested in running like Dask and things like that. So, and I think that's really started like much more recently. I think like academia has been ahead of the curve here. So I would suspect that over the next, already the situation for that is much better now than it was a year ago. And I suspect over the next year or so, being able to teach like big data for different definitions of the word big will be, less bespoke in the Jupyter Hub world.
I feel like also like an important thing to point out here is that Jupyter Hub is not a computation engine, right? Like Jupyter Hub is not a database engine. What Jupyter Hub is a connector. It's like an integrator, and it can connect to computation engines that are scalable and distributed and whatnot, and it can connect to distributed, databases and cloud storage and all that kind of stuff. But it's not responsible for actually doing that work. So in a sense, like Jupyter Hub's hope, and I think this is what's going to happen, is that, as Yuvi said, like as that space proliferates, as there are more tools and services and open source projects and formats that make it easier to scale your computation, Jupyter Hub wants to be there waiting to facilitate you using those tools. So it doesn't need to solve the problem of like, distributed cloud computing. It just needs to use something like Dask Gateway and know how to like send commands to Dask Gateway, that'll be the thing that actually handles that problem. So part of the solution here, I think, is scoping Jupyter Hub so that it does like one thing and it does that one thing well.
Yeah, I mean, certainly Yuvi, that we have this potential collaboration with the genetics data, which for me is like another level, another order of magnitude of both the size of the data set and the compute time that it takes. And it's interesting how the same tools can scale into that space. That's just so much more compute and so much more memory.
I think another important piece here is that in the future, and I'm going to share a link to a project called Pangeo that's really interesting. Pangeo is this large collection of online Jupyter hubs and binder hubs to facilitate geospatial analytics in the cloud. And one of the important things that they've learned, and I think something that the scientific community really needs to get behind, is the idea that in the future, I think increasingly data will be stored on the cloud, in cloud resources, especially these extremely large data sets. But we don't necessarily have control over which cloud that data is stored in. And I think that's why it's really crucial that we have a collection of tools that operates the exact same way across every single cloud provider. Jupyter Hub is one example of such a thing. And Pangeo uses Jupyter Hubs in a very quick ad hoc basis. Like they'll get a 200 terabyte data set from a climate group or from a satellite. And that satellite group has a deal with like AWS or with Azure or with Google Cloud. So that's just where the data is, full stop. What they can do is spin up a Jupyter Hub on any one of those three providers in the same way that they would, on any of them. So there's no difference between spinning it up. And that means that they can kind of standardize the experience between those providers, regardless of where the data is. So they don't have to like say, oh, like the data happens to be on Google Cloud, so we have to use like the Collaboratory or some like Google AI notebooks, or, oh, the data is on AWS, so we have to use SageMaker. They can use the exact same infrastructure across all of them. And I think that's a really important future that we should be working towards in the scientific and the educational community.
Thank you, Chris. That's totally awesome. I really quickly want to jump back to Chris Pyles, who does have an internship this summer that he's skipping out of to be on the panel. So does anybody have any more questions on Otter? Anybody have any more Otter related? Holdgraf, I don't know if you saw the Otter, Chris Pyles just posted his Voila app. That's from our class.
Oh, that's actually pretty cool. No, I didn't see that. So just really quickly to provide more detail there, somebody in the chat room had asked about like, providing Voila apps and dashboards to students and whatnot. And I guess if you look up, maybe I'll just copy paste that again. Other Chris just posted a link to a Voila app that they were using in one of their courses.
And I will say from my perspective, it's fun. I'm the instructor on the class, but we have an amazing team of students that make awesome curriculum, and Chris Pyles is on the course team. So in the last year, that's definitely where Otter has been tried out in various of its 0.1, 0.2 iterations. What does it say? We're at 0.47. Chris Pyles, I'm going to ask you a question directly. What do you think the service future is? Do you have a vision for will it be a standalone thing? Will everybody run their own thing? Will there be some sort of non-profit binder version of it? Suppose it was a year or two from now. What do you think? I mean, OKPy has a place where people can go and find it and sign up their course. You want to answer verbally, or you're just answering in the chat? All right, so he says the future.
Oh, yeah, sorry. I would say Otter Service is something that we built, but not necessarily the future per se. I think LMS integrations and fitting Otter into existing infrastructure, maybe as a hub managed service or something like that, is where Otter is going to come in more than deploying a completely separate VM for grading. But that's something that's always evolving, so you never really know.
Yeah, I think there's a lot of LMS integration possibilities for certainly for Jupyter Hub as well. I guess we saw some demos in the last panel where it was you were in your Canvas assignment and your Jupyter Hub showing up in your Canvas assignment for Vocarium. Definitely. Not the way we're doing it right now, but it's a possibility that things become more and more interoperable that way.
And that kind of speaks to the value of standards and protocols and certain patterns that are just defined community norms, so that if you want to add an integration with a new thing, all you have to do is follow this set of patterns, kind of the same way that a lot of software ecosystems will create a plugin extension mechanism, that kind of thing. It's really important for the Jupyter project to try to develop those kinds of patterns and to sort of promote them, because that's what makes it easier for other organizations like a Vocarium, like a Gradescope, whatever, to be able to plug into all of this pre-existing infrastructure.
All right, thanks, Chris Pyles. Yeah, so I guess Debbie, I guess, you know, another question that I have is related to Debbie's question, making things really easy and seamless for students versus like teaching them tools. And I think that there is this sort of interesting thing that's like, that I like to say is that, you know, teaching students Jupyter notebooks and Jupyter Hub, which is the same thing that they could do if they were doing data science at a big company, in that it's like it would just modularly build to that. Like you're making them familiar, like at their first building block with something that building blocks up to real high levels of complexity. I don't know if Yuvi and Chris, you want to talk about that. Just, you know, there's something about designing things well so that they're simple enough for the first user, but they're like robust enough to do, you know, the satellite data in the terabytes later.
Yeah, I mean, my take on that is always things like hosted services, whether it's a Jupyter Hub or any other kind of online hosted service, they don't allow you to just like skip teaching people the kind of nuts and bolts of how this kind of thing works, but they allow you to be much more precise about when and how you teach those concepts to people. So like right now, if I have an introduction, well, say 5 years ago, if I was teaching like an introductory statistics course to people who didn't know anything about programming, didn't know anything about statistics, but I wanted to use Python, then like the first 2 weeks of the course would be just me trying to figure out how the heck to install Python in everybody's laptops, you know? And by then you've lost a bunch of students because they're discouraged, because they're like, why the hell am I dealing with like installing an Anaconda distribution? What does that even mean? This is a statistics course, you know, I'm not a computer science major. So if you have things like hosted services, you can leverage them when you need them. And then you can choose when during the course you say, okay, this week, like week 7, we're going to cover moving all of this workflow onto your own laptop. And it can just be a set of materials that you would cover like anything else in a course. But you can choose when is the right moment to do that as the instructor, which I think is really useful.
Xiaodan has the comment about the accessibility for Jupyter Notebook.
I can really quickly say something about accessibility in the Jupyter ecosystem. And I'll link also a repository here. So accessibility is one of those things that is extremely difficult to do properly. It actually requires a lot of expertise, both technical expertise as well as domain expertise, in particular on topics of accessibility. In the Jupyter ecosystem, it's something that we've been working towards for a long time, but there's still a ton of progress that needs to be made. There are definitely things about the Jupyter ecosystem that are not very accessible friendly. I think it'll be easier for things like Jupyterbook because it uses more traditional and simpler web standards. But for things like the Jupyter Notebook interface or for Jupyter Lab, that's something that there needs to be improvement on. That said, it's important to remember that Jupyter is largely a more or less volunteer-driven organization. It doesn't have very many resources itself, and it relies on contributions from either organizations that use it or companies that use it as a part of their products, as well as by organizations like Berkeley that sort of build it into their own workflows and whatnot. And so accessibility is something that's going to happen when community members in the Jupyter community sort of contribute to making it happen. And that might mean something like, you know, a company looks at the Jupyter interfaces, sees, oh, these aren't accessible enough for our needs. And rather than deciding to just go and create their own interface, they decide to upstream improvements to Jupyter to make it accessible instead. And that's kind of a complex dynamic that can go a lot of different ways. But that's the kind of thing that's going to lead to better accessibility in the Jupyter ecosystem. I linked to a Jupyter repository that is kind of a meta repository for accessibility. There's been a recent kind of push to try to improve this across a bunch of different Jupyter tools. We were actually going to have a big kickoff workshop in April before like the entire world fell apart, but that'll be restarted at some point soon. And if you're interested in having conversations about accessibility and you have opinions or you have experience, check out that repository and please do pitch in.
Awesome, thank you. So another one, and maybe I should put this back to Yuvi or Ryan. You know, in the last panel, it was like, here's these commercial solutions that can sort of like give you some hosted thing. And a lot of what you guys are doing is like building the tools and writing the documents so people can roll their own. How can you like give a pitch? Suppose there's a, you know, a bunch of people on this call that are going to have to make these decisions. How can you give a pitch for like what's the benefits of rolling their own and what's the benefits for like taking on their own Jupyter Hub?
I know Chris has been responding a lot, but I think this is one of those things where he has a pretty nice answer.
Okay.
Wait, what's the question again? Sorry, I was responding to things.
Yeah, just like, you know, make a pitch for people making their own Jupyter Hub.
Versus like commercial offerings that you can just pay money for and get some variant of an open source distribution for you.
Yeah, I mean, I think that, you know, as with anything, right, you have lots of different options, and those options have various pros and cons that come along with them. As you can probably guess, what we prioritize at Berkeley and what we prioritize in the Jupyter project is flexibility and choice, and having a collection of tools that are like community-driven, peer-produced tools that are both like produced and led by that open source community of people, which I think is really important. Importantly, related to that is that those tools should behave the exact same way across all the different cloud providers, because you don't know which cloud provider you're going to use a week from now or 6 months from now or 2 years from now. And I think that there's risk associated with using a cloud provider specific interface. The providers are doing a better job lately of building on top of standards and things like that. A great example of a standard is the .ipynb file, the Jupyter Notebook.ipynb file. That's like a file that you can take with you and go to a variety of different interfaces and services and whatnot. But I think at the end of the day, what we should all be striving for is to have control over our infrastructure so we can run it wherever we would like to. That said, like sometimes you don't have a choice. You don't have the expertise, or you don't have the time, or you don't have the money to manage your own infrastructure. And hopefully in the coming months and years, we'll see more organizations that can try to manage that kind of open source, like truly vendor agnostic infrastructure in the way that, for example, Red Hat Linux provided that role in the early days of the Linux ecosystem. But I think that, you know, at the end of the day, it's something that it's a choice that you need to make for yourself. I would say I would try to be skeptical about like free online cloud offerings in general. Just because anytime someone gives you something for free, you should like try to figure out why, and think about what are the sort of behavioral patterns that using a particular service is going to move you into. Like, is it going to make it harder for you to move from that service to a different service? Because thinking about those things ahead of time, I think, is important. Sometimes you still decide to use that service anyway, but I think that you should consider the different pros and cons about how a decision now is going to impact your workflow in, like, again, 2 weeks, 6 months, 2 years, 5 years, that kind of thing. I'm not sure if that answers the question because I didn't exactly catch the first question. So I apologize if that was like a total.
Are we going to be using Jupyter Notebooks in 5 years?
Say that again?
Are we going to be using Jupyter Notebooks in 5 years?
Yeah, I think we'll be using IPynB files in 5 years. I think that what it looks like to use a Jupyter Notebook will be very different 5 years from now than it is now. You know, I mean, the notebook format, at the end of the day, it's just a blob of JSON that you can do all kinds of things with, right? And even just in the last few years, we've seen this like proliferation of really interesting notebook tools. There's the classic notebook interface, but now there's like Jupyter Lab, there's Interact. There are like 4 million startups that all have their own notebook interface. All the cloud vendors are like creating their own notebook interface. And I think that there's just going to be more innovation in that space moving forward. What I hope is that the tools that emerge from all of that are tools that are like truly kind of community-led, community-driven, and that work interoperably across all of the different infrastructure that's out there.
Yeah, it's funny. Nobody has brought up Interact at all. It's like definitely not enough legs on that project. I could see that definitely being a future.
Yeah,
in the teaching space.
Interact is a really interesting project. It's in many ways, it's kind of like Notebook, the classic interface plus, you know, they try to kind of like build on top of the patterns that were there. It looks much more familiar to the classic Notebook interface than something like Jupyter Lab does. And Interact is a community just like the Jupyter community that's largely volunteer driven and largely under-resourced. So I recommend that anyone here check it out and offer to pitch in as well. They're also like a really, really great inclusive and welcoming community.
Yeah, I could definitely see a future being in Interact.
They also have a lot of components too. So like Interact is based on React, which is a JavaScript framework that a lot of people use. And the design of Interact is in a way that the interface elements themselves are meant to be reusable. So I think that some other products and whatnot are actually reusing pieces of Interact. They're just not using the full-blown Interact application.
Right. Right. All right. Anybody, do you guys want to wrap up in any way? Or I think there's a lot going on in the chat. I will have to jump off in a little bit for the next panel. I want to thank everyone for not just leaning in and coming to this panel, but all this awesome work that you're creating for the world and giving out for free on GitHub and documenting for the world to use. I think it's really amazing. And I like this forum as a way to get, you guys in front of potential future user base in the education space. Whereas there's lots of different people that are using Jupyter Hub that aren't educators, but it's cool that you're you're engineering things for education. They're going all over the world for other things as well. But, I think that you're all basically excited about the public mission of it and the public education mission of it. Yuvi, any parting words?
Thanks for moderating this, Eric.
Okay.
Thanks, Eric.
Yeah, I'm sure there's lots of innovations and stuff that we just don't know about that are being quietly used by a class of 50 people somewhere. So you might not think what are you doing is cool, but just please post on the Discourse channel on the public GitHub or somewhere so other people can also see what you're doing and then adopt it for themselves.
Yeah, and people in the chat were asking how to get in touch with Yuvi and Ryan, and they would prefer that you just ask questions into the Discourse channel. It's important to them culturally that your question, and I just want to explain this to other people, your questions aren't ad hoc questions to Yuvi. If you put them in the Discourse channel, they become part of a public conversation. Some problem that you have may escalate. It's a way for people asking questions to become part of a bigger project and not just a one-to-one thing. So that's an important cultural choice about what open source is.
Also, thanks to Yuvi for staying awake until 1 o'clock in the morning to talk to us.
For the third time this week.
Oh no, the first time was to 5 a.m.
Right.
And also thanks to everybody here for coming and joining in. We really appreciate the kind of dialogue, and it's exciting to talk, in a two-directional way with people that are using these tools. Okay, thanks you guys. I appreciate it. You can stay on. I'm going to jump out if you want to, or just keep answering the chat. But I really appreciate your time. Thank you. Okay, I'm going to go eat lunch. Yeah, I need to do that too. All right. See you all. Bye.
All right. Bye.